Hello children, welcome to channel Sube. Children, today I am going to discuss question number 23 from the MCQ part of 2022-23 Physics new syllabus paper. The diagram shows a circuit having a battery of e.m.f 6.0 volt, a 3.0 ohm resistor and a 6.0 ohm resistor connected in parallel. When the switch K is opened, reading of the ideal ammeter is 1.5 ampere. What is the ammeter reading when the switch is closed? The answers: first one 1.0 ampere, second one 1.2 ampere, third one 1.5 ampere, fourth one 2.0 ampere, fifth one 3.0 ampere. So children, I think the battery in this circuit has a internal resistance. They have not mentioned anything about that. I doubt, therefore, that is the problem in this question. We have to first of all solve. The ammeter is ideal. They have said that ideal ammeter, but about the cell they have said nothing. But normally in all the past papers they say that it has negligible internal resistance, but here they haven't mentioned that thing. So therefore let us try to check what is the internal resistance according to the current is giving here, according to the current given. So we can calculate the internal resistance. So first they say the switch is closed. The current is 1.5 ampere when the ammeter reading, and that is what they ask. First they say when the switch K is opened, as it is now this circuit, the current is 1.5 ampere. So in this circuit the current is 1.5 ampere when the switch is opened. When the switch K is opened, reading of the ideal ammeter is 1.5 ampere. So now it is open. So since the switch is opened, so there is no current here, so this resistor is useless, therefore I remove it. So the circuit is like this, the simplified form. So the current is going only through this external resistor, capital R equals what? 3 ohm. Capital R is 3 ohm, current is 1.5 ampere, capital E, e.m.f is 6 volt, then simple R we don't know. That is what we have to find out. Simple R normally we denote here close to the cell. So let us use the equation E equals I times R plus R equation. This is the equation that we use for ideal circuits. So E is 6, current is given as 1.5 in brackets, capital R is 3, simple R we don't know. So 6 divided by 1.5 equals 3 plus simple R. So here 4 equals 3 plus simple R. Then simple R equals 4 minus 3 is 1 ohm. So it has a internal resistance. So now let us use it. Here we can write R equals 1. Now what they have done, this switch is closed. What is the ammeter reading when the switch is closed? So now the switch is closed, now current is passing along this resistor as well. So both all together go to the battery, coming from the battery. So what they ask is this current I. So now these resistors are in parallel, these two are in parallel. If they are parallel, what is the equation? You can use 1 over R equals 1 over R1 plus 1 over R2, or otherwise you can use directly the resistance, the equivalent resistance is equal to multiplication by sum. That means R1 R2 divided by R1 plus R2. That is the simplified form of this original equation. This one is not anything else. This one is not a new one. It is the simplified form of the first equation. So multiplication divided by the sum. So that is how you have to keep in your mind. Multiplication divided by the sum is the resistance, equivalent resistance directly, not 1 over. So now what is it? You don't have to write all these things. You can do it by heart, by mind. So how to? 6 times 3 is 18. The sum is 9. 18 divided by 9 is 2. The external resistor is 2 ohm. So we know simple R is 1. So let us write the equation. E equals I times R plus R. E is 6. I is what we have to find out. Capital R is 2 plus simple R is 1. So I is 6 divided by 3 is 2 ampere. 6 divided by 3 is 2 ampere. So the answer is this one, fourth one for this question. Question number 23. So let us check the answer sheet. 23, fourth one. Right. Fourth one is the answer we also obtained. Children, I think this question is an easy one. So you have to guess. First of all, you have to doubt what is the trick here in this question. Whatever the question you get, there is a trick they have. There is a trap or a trick. So you should be able to guess it at the beginning. So children, let us do some what we call the target questions now. Children, here is our target question. The first one, target question number 1. Read the question carefully. I have done some alterations. So you have to now answer it on your own without looking at my answer. Pause the video. Now start. Since you have paused the video, I am going to start now. So what they say, the current is, when the switch is opened, the current is 1 ampere here, then 1 ampere. So we don't want this part because it is opened, because switch is opened. So these resistors are in series because all the current that has gone through this first resistor must go through the second resistor as well. So these are in series. So capital R is, if they are series, we can add directly. 3 plus 3 is 6. So we have to first find out simple R, because in this question they have not mentioned about the battery, that the internal resistance is negligible. So therefore we have to assume that there must be some value for simple R. So we use that equation, E equals I times R plus R. E is 9, I ampere, 1 ampere, capital R 6 plus simple R, that we don't know. Then 9 equals 6 plus R. So simple R is 9 minus 6 is 3 ohm. Now let us go to the second incident. So what they have done, first of all we have to indicate that this one R is 3 ohm here in the diagram. So they have put on the switch like this, closed. So now current is passing through both these resistors like this, and all together go to the this resistor, and through that go to the battery. So now these two resistors are in parallel, so therefore we can simplify it, get the multiplication. 6 times 3 is 18, get the sum. 6 plus 3 is 9, so 18 divided by 9 is 2. So we can draw one single resistor whose value is 2. 2. So now these are in series, so directly we can get the sum. Add 3 plus 2 is 5. 3 plus 2 is 5. So we can now draw only one resistor whose value is 5, equivalent value, equivalent resistor. So now we use the same equation 9. Here current we don't know, that is what we have to find out. 9 equals I times capital R is what now? 5, only 5. We have simplified. 5 plus simple R is 3. Then 9 divided by 5, 6, 7, 8. Divided by 8 is I. So 1 times 0.1, then to 10, again 1. Only for one decimal places they have, one decimal place they have calculated the answers. 1.1. So this one is the answer, second one. What happened to your answer? Correct? Then if it is correct, you are genius. Otherwise you have to do more exercises. More exercises you have to do. Do this exercise again and again. This one, or whatever you have been given by your teachers, also you can do again and again. Then only you will develop. So let us go to the second target question now. Children, here is our second target question. Target question number 2. I have changed the circuit from various places, so you can try this. Watch the video honestly. Don't look at my answer. Pause the video now and start. So since we have paused the video, now I am going to start. So what they say at the beginning, when the switch K is opened, reading of the ideal ammeter is 1 ampere. So here 1 ampere flows. The current is 1 ampere. Switch is open, then this part is not useful. Let's close it, like delete it like that. So these two resistors are now in parallel. These are now in parallel. What is the resultant resistance of these two? 6 times 3 divided by 6 plus 3. Then 18 divided by 9 is 2 ohm. Then we don't have to write all these things, we can do like that. So instead of this we can write 2 ohm. 2 ohm, one resistor, 2 ohm. Then what happens? These two are in series or parallel? Series. Therefore we can add 3 plus 2 is 5. 5 one resistor we draw one resistor whose resistance is 5. So simple R we don't know, so I don't write the equation. E equals I times R plus R. So 9 equals I times 1 R plus R, 5 plus simple R. Then 9 equals 5 plus R. Then R equals 5 9 minus 5, there is 4. So here we write now simple R equals 4. Then what they do, this switch they have put on the switch. Then what happens? How does current flow? Begins from here and goes through this ammeter, because that has no resistance. So directly go through this key and to this resistor, through that to the battery. Does current flow here? No. Does current flow here? No. Why? Because there is a short circuit here whose resistance is 0. So this line has no resistance, since these have resistances. So therefore the current always passes through the minimum resistance line. So these resistors are not useful now. They are not in use. Current is not passing through these two resistors. So only current is passing through this key and key line. What is the word we use for such an incident? Short circuit. The two resistors are being short circuit. The both ends of a resistor is connected by a conductor, is called short circuit. So now only this one is the resistor we have in this circuit and the internal resistor. So capital R equals 3, simple R equals 4, E equals 9. Current is what we have to find out, I. So E equals I times R plus R. E is 9, I we don't know, capital R is 3, simple R is 4. 4, 5, 6, 7, I is 9 divided by 7, then 1, 7, 8, 9, 20, then 2, 7 times 2 is 14. So 1.2 is the answer. 1.2 ampere. This one, third one is the answer. Children, what happened to your answer? If you were successful, you are genius. Otherwise you have to do more exercises like this. So what is what do we call what is the definition of short circuit? This circuit is this two resistors, that means these two are got short circuit when we put on the switch. Short circuit. Connect. So if they asked in your essay paper what is short circuit, what is meant by short circuit, so you have to write connecting the two ends of a resistor by a conductor is defined as, or is called short circuit. So that is what had happened here in this circuit. When the switch is on like this, the current directly flows through this one, not through these two resistors. So that means short circuit. The resistor the two ends of these resistors means these two ends are connected by this wire is a conductor connected like this, and also this one also connected like this. So that is why we said it is called short circuit. So children, I think the way I explained might make you happy, because I explained everything, I think, and I explained even what is short circuit. If you have forgotten, sometimes you may not know to write it, even though you know what is short circuit, but you may not know how to write it as an answer. If they asked, you know that there is short circuit, but you can't collect words to write what is it. Sometimes that sort of problems children have. So now I gave it even as well. So children, let us wind up today, because now it is 15 minutes we have used. So originally we answered this original question and discussed it, and I made this target question for you, and we discussed it, and then I made this target question as well, and I explained it, and you answered. Sometimes you might got the correct answer, sometimes may not. So but however we discussed it. So children, that is enough for today, because now time is up. So children, if you are happy, please subscribe my channel. Leave the page without owing me. So you can, then what you can do, share my link among your friends, and help that way to increase my audience a little bit. And also press the bell icon, then you will get the message as soon as I upload it, because sometimes I would not be able to upload the video at the proper time, at the correct time, that means 6 o'clock, because sometimes I uploaded but I forget to publish it. So that happened last day. So however, as soon as I upload it, you can get the message. And also press the thumb up icon, give me a like, because then only my video is pushed forward by the YouTube automatically, otherwise they will place it at a corner. So children, thank you very much for watching my videos, and thank you very much for subscribing my channel. Then see you tomorrow. So long, goodbye.